Good afternoon and welcome back to the homestead. It's a beautiful sunny warm day out and I want to take a few minutes and talk about communications. So we get a lot of questions about communications. Sue and I are both amateur radio operators. We get questions from many different directions, like some people question how are we going to talk to each other during a time of crisis. Some people are concerned about when everything else collapses or just things that are out of your control. However you may want to look at that, for whatever reason you want to look at that. If you're concerned that society may collapse around us and that all communications will fail and you'll be in the dark, amateur radio is a great way to go. If you're concerned that systems may get overloaded, on 9/11 for example, cell towers were way overloaded, communications were failing everywhere, amateur radio still works. So one of the things I wanted to talk about a little bit is how it works and the different types of what it is, different types of radios, different bands we use, and how far you can talk and what you should expect. The first thing I'll point out is that it's antenna to antenna. So for the most part, all your amateur radio is talking from one radio to another radio unless it's using a repeater. There are some digital modes out there. There's some stuff called like DMR. I think Yazoo has a version of it. I don't follow the digital stuff a lot just because the digital stuff does require internet. And again, we're trying to get away from that if the goal is really to be able to just talk around the world on your own power without any, third-party items, if you will. So when you're looking at radios and you're looking at communications, there's three different areas you're going to look at. They have what's called UHF for ultra high frequency, VHF for very high frequency, and HF for high frequency. And all that means is the different frequencies. So I have a band plan here, and I'm not going to ask Sue to zoom in on it. I'll leave a link down below. But this basically does a few things for you. This band plan shows you where you're allowed to operate in every frequency that we work based on your license. I should have started by saying that amateur radio requires a license. It's a pretty straightforward process. You can find a club in your area. You can go to arrl.org, I believe it is, and we'll leave a link to that as well. Find out where they're doing testing. You can study for your technicians. You can move on all the way up to your extra. So, it really depends on what your goal is here. The higher the frequency, the shorter the distance we talk, if you will, I guess is the way to say it. So, or however you want to look at that in terms. So this particular radio right here is a little 5-watt handheld. It works on VHF. So this is down in what we would call the 2-meter or 1.25 meter area, or 70 centimeter. 70 centimeter is UHF, but in that general rule, let me make sure I'm telling you that correctly. Yes, 70 centimeter is UHF. So the HTs are most always going to be in either UHF or VHF. Your big radios are going to be in all the bands, not necessarily all the bands in one radio. With an HT, with these two radios, both being 5 watts, we could probably expect to talk to each other 5-6 miles apart, give or take. I take this radio and hook a good antenna up to this radio, and now I might be able to talk between those two 20-something miles. And then I can go a little bit farther and I can do what's called a repeater. And we can do a whole series on a repeater, but a repeater is basically two radios. They're made special for the purpose, but they're two radios connected together with electronics. So when I talk on this radio and I try to talk to somebody, this radio hears it and it retransmits it out at a lot higher power. So what that means for you is that like an HT like this one, talking on 2 to 5 watts, could go a couple miles to a repeater that then broadcasts out at 20 or 30 or 40 or 100 watts and goes a lot further distance. So what you have to decide is what your goals are, what you're looking for communication. If you're looking for something to be able to talk to your neighbors, VHF, UHF makes a lot of sense. If you're looking for something to get news from around the world, then you're going to be into HF. And there's a whole different myriad of radios. So like this radio here is a single frequency. This does just 440 or 70 centimeters. That's all this radio does. You can buy this same brand in 2 meters and all the other different frequencies, but they're a single band radio. This particular radio right here, which is the Yazoo FT857, very versatile radio. This does all bands and all modes. So this is going to do 2 meters, it's going to do your 440, it's going to do all your HF bands for talking around the world. It is portable, as you can see. The other cool thing about it is it runs on 12 volts. So I always like to say that the reason I get an amateur radio is because I can take a radio, a piece of wire, and a 12-volt battery, and I can talk around the world. That particular radio right there from Central Maine, I talked to Moscow, Russia one night in my truck going down the highway at 65 miles an hour. Pretty cool things when you think about it. This radio is quite similar to this radio, except for a lot more buttons and knobs and switches and doodads. So it's going to have more options, but at the end of the day, it does all the same stuff. It's going to cost about twice as much as this radio. This radio requires 120 volts. You can get these in 12 volts or you can get them in 120 volts. Most of the amateur radio stuff is going to require 12 volts when it's a larger radio. This radio will output 100 watts. This radio will output 25 watts. So again, that wattage is not completely relevant, but it's something to pay attention to. If you're talking on a handy talkie, an HT, again, you know, your distance is limited to the power of the radio because of the antenna and the radio. Antenna is probably the biggest thing. You can do so much with an antenna. These antennas here are basically just a dummy load, just to present a load to the radio. They don't really match well, they don't transmit well. You could get a better antenna and probably double your distance, or you could actually put an antenna up in a tree and hook it up to this with a cable and then talk about as far as you could with one of these. So a lot of the problems you'll see in communications is the actual feed lines and antenna, not so much the power of the radio. Common misconception is just to turn the power up and let's get through. That doesn't always work. You know, generally speaking, if the hardware is in good shape, the power is not quite as critical. So if you're looking to get into something, if you're looking to, you know, keep tabs on communications, let's say there's a 1 second after event. For those of you that have read the book will know what I mean. These radios here would all be basically paperweights because of the EMP. Now, if you had them in a place where they're safe, a Faraday cage type thing, or if you had an older radio that was a tube type radio, it would survive. But let's just say that we had a radio that survived that. We could actually take this radio, we could hook it up to the battery on our truck, car, ATV, anything, and then we could take a piece of wire and throw it up in a tree, and we could talk around the world on that radio. So 20 meters is probably one of the more favorite bands for talking long distance. And 20 meters, you can build an antenna out of literally any wire you could find. You could strip wire out of the wall in here and build an antenna for 20 meters. So one of the things we're going to show you is a little bit of an explanation of VHF, UHF, and HF and how the communications work. So I'm going to have Sue pan over to the whiteboard here, and we're going to draw some pictures. And I'm like at 3rd grade level with art, so you guys will have to tolerate me. All right, so we got you zoomed in here. The green circle is our Earth. You know, it's curved. This little red thing and this little red thing, this is me over here with my handy talkie talking. And the blue line sort of shows you line of sight. So in VHF and UHF, you need to be able to basically see the antennas from each other in a line of sight. It can be a couple trees in the way, you know, you might not physically see it because of the mileage, but it cannot be around the curve of the Earth, right? So you see what we got happening there. You can see where you wouldn't hear me if I'm talking over here. But now let's take this blue line out and let's try not to erase too much of the Earth. Let's go ahead and throw a repeater in here. Now you got this repeater, which is usually on a really tall tower, really good site, and it's basically listening and talking at the same time. So now you can see where when I talked on my HT over here, and you see it went through like that, the repeater hears it. Because the repeater immediately starts transmitting it back out, and now the other radio has heard it. So in a type of, disaster, if you will, this setup works well on VHF and UHF to get you probably 50 to 60 miles, I'm going to guess, from here to here if everything is split in equal parts. Some places, like here in central Maine, we have this wonderful system put together by a fellow ham radio operator that covers almost the whole state, and it's all radios. There's no computers in it anywhere. So you can talk from all the way down in southern Maine, all the way up to northern Maine, through the repeater system using these same handy talkies. But this is all mechanical, radio waves and batteries, if you will. A lot of the repeaters are on sites that are backed up by batteries and generators. But let's say you want to go a step farther, and let's say, go ahead, you don't have to move. I'm just going to grab something to erase the whiteboard. Let's say you want to go a step farther and you wanted to talk all the way around the world. Or you just want to be able to listen to what's going on. So you may have played a shortwave radio back, as a kid or in your time. But here's the Earth, and we have this atmosphere thingy around the Earth that keeps us alive, holds all of our stuff in, yada, yada, yada. I'm not going to try to claim to be a scientist. So now what happens on HF, like on 20 meters, for example, is I'm over here with my radio, and I transmit, and it bounces off kind of bounces around like this. So that radio signal is all around the world because it's bouncing off the atmosphere around us instead of line of sight. So it no longer requires line of sight. A lot of times it's a single bounce like that. It doesn't necessarily bounce multiple times. So the type of antenna you have, the mounting of your antenna can affect that angle. You may get a steep bounce, you may get a gradual bounce like that covers a lot more earth. So that's just something to know, that while every radio has its purpose, I guess is the way to say it, the HF radio, like the 857 we showed you, talking on like 20 meters, is great for talking around the world. And it requires the least expensive hardware as far as antenna and feed line. It does require a little bit more expensive radio. But one of the nice things about an HF radio, like on 20 meters, and we'll try to leave some links down below, maybe we'll do some videos on how to build them. But if you need to build an antenna for 20 meters, you're basically going to take a piece of wire, and you're going to take another piece of wire, cut to the right length, and I'm not going to quote the length here because I don't remember it off the top of my head, but I think it's somewhere in the 12-foot range per side. So now you have roughly 24, 25 feet of wire, and you have this coax that goes to the radio and screws into the back of the radio, right? And on that coax is a braided shield around the outside, and that would come out and go to one wire, and there's a center conductor that would go to the other wire. And it really is that simple if you need to make an antenna. You take your RG8 coax, if you will, you strip back the outer insulation a little bit, and you peel the braid off one side and the center conductor off the other. You solder some wire to it, you hang it up the right length, cut it off. You can tune it with a tuner, and we can show you a lot of this stuff in future videos. Or you can do the math and do the formula and check it. The bigger radios that we showed you will have a tuner built into them. The little radios will not. If you tune it correctly, you don't need a tuner, but if you don't get it quite right, you can use a tuner to bring it down. So there are things called standing wave ratio that you'll hear about, SWR, and in a perfect world, you would have a 1-to-1 match. And what that means is when this radio transmits, say, 50 watts of power out the feed line, all 50 watts of power would be radiated out the antenna. Now, there is no perfect world at all, so in most conditions, there's going to be some reflected power, and what that means is while this radio is transmitting 50 watts, maybe only 40 watts is going out this way, and 10 watts is being reflected back down into the radio. That's called reflected power. So you would expect some of that, and generally for us, a 1.5 to 1 SWR is roughly about the best you're going to hope for in some kind of compromise situation. Most of your radios will tolerate, I think, about 2 to 1 before they start to fold back or do something weird. But that's kind of it in a nutshell. You would end up, if you wanted to make an antenna like that one I just showed you, the couple tricks and secrets. One is that if you can hang it from the center. So what I do is I take a piece of 1.5" PVC pipe, about 6 inches long. I take an end cap for that PVC pipe. And on this end, I actually put in a little hole, probably big enough, probably about 1/4 inch. And I run my RG8 feed line up into that. And then I drill a hole in the side here, like this. And then up here I drill smaller holes and I put in eyelets. Like that. So then what I do is, up inside this piece of pipe, I've got my shield that comes out one side off my wire. And I got my center conductor that comes out of my wire. I solder them to my actual wire I'm going to use for my antenna inside here, and I bring that wire out, tie a knot around that, and then I can go like that. And on the end of it, you can get these plastic insulators that have holes in them, and you can tie this to a tree with rope, and you can run the wire back and twist it around itself like that. And what that lets you do is you're getting ready to tune. So lets you untwist it and lengthen it or shorten it until you're happy with it. And then at the top of this, I put another eyelet like that. Just a little, you can buy them at the hardware store, just little stainless steel eyelets. So once you've got that built, and we'll leave a link to these antennas. You can actually buy these antennas all assembled for 30, 40 bucks. Once you've got that all built, what you really want to do is throw a rope up in a tree. And you want that thing to look, the rope comes down to the eyelet. You want your antenna to look like an inverted V in a perfect world. And there's height above ground. It does matter some, the longer the antenna. So if you're on 20 meters, it doesn't have to be quite as high as if you're on the other ones. But that's kind of what you're looking for, is an inverted V, and your feed line comes down to your radio like this. So with that, that wire is going to transmit like a donut, if that makes sense. So imagine this is my wire, this piece right here. Let me unscrew that so it's a little bit less confusing. So that's my wire, right, for my antenna. So that's going to radiate a signal out, all the way around it, straight out. So if I put this wire like this, and I put it in Maine here, I put it north and south, that means I'm transmitting east and west, which is ideal for me because then I can transmit over to the west coast of Maine, the US. I can, transmit to the east coast, and those basically get me around the world where I want to be. So you can play with the orientation of that wire to direct that signal where you want it to go. So it's what we'd call an omnidirectional antenna, but it's omni into the ground, into the sky in two directions. Whereas when it's on the HT, you see it's omnidirectional this way, and it goes all the way around me. So it's going that way, that way, that way. So that's something to be aware of. The other one is polarization. So we have, in the VHF and UHF world, almost without fault, it's always going to be what we call vertically polarized. So if we took these two HTs, put them 3 or 4 miles apart, this one, talk to this one, you're going to hear it. If I turn this one like this, so it's horizontally polarized, you're probably not going to hear it, even if I turn it like this, because of the way the signals work. So that's just something to be aware of. I know there's a lot of stuff I'm not covering here, but the most common question we get is, in a doomsday scenario, how do we talk? How do we communicate? And the long and short answer is, you don't want to rely on something else. We all carry one of these things around with us. These are amazing. I can Google anything right now and figure it out. I can call anywhere. I can get on the internet. But in a doomsday scenario, there's not going to be any internet. Or if you're in a case where your government maybe is trying to censor you or censor what you hear, they have control of that, right? And you don't. So the big thing with the amateur radio is that you have control. You have the ability to do what you need to do. You can talk around the world, you can talk to your neighbor, you can set it up however you want. That's the big thing. The other two things, the other thing I wanted to point out was you can learn what's called Morse Code, or CW, and that actually travels farther than voice does. So when we're talking, it's probably farther down in the weeds we want to go, but if you looked at a radio wave going through space, it's going to be, let's say, trying to figure the best way to analogize this. Let's say this is voice. So this whole thing here is a radio wave going through space. It's that wide, plowing the channel through space, right? So think about driving down the road if you hand out the window, right? If you get your hand out the window like this, wind pushes it back. If you turn your hand like this, it's not so bad. So this is your voice, and it's quite wide this way. Now on Morse code, it doesn't take up as much space. So it's a lot thinner going through the space, so it'll go farther. So that's kind of a poor analogy, but the best analogy I can give you is think about your hand out the window. When I'm talking, the hand is like this going down the road, it's catching a lot of wind. It takes more power to get it farther. When I'm sending those dots and dashes in Morse code, it's going to be more of like hold your hand out the window like this, and it's more streamlined, and it's a little easier. It goes a little farther. It takes a little less power to get at the same kind of distance, and less conditions, favorable conditions, if you will. So that's kind of where we're at. I think that we can do some video series on antennas, setting some of this stuff up. But like I say, the most coolest portion of it is, and we'll have to actually do this video. Literally, you can take a rock, tie a rope to it, throw it up over a tree, haul an antenna up in a tree, hook it to that radio I just showed you, plug that into the cigarette lighter. Not the best idea, actually. You should hook it to the battery, and we'll talk about that in a second. But you can plug it into the battery of the vehicle and talk around the world. Whereas, everything else requires something, requires internet, or requires cell phone towers. And one of the problems with all of this stuff that we use, like these cell phones, is that all the infrastructure is built for the average load. So if you're Verizon or US Cellular or T-Mobile, and you're going to put a cell phone tower in up here by my house to cover this area, you're going to look at the demand and say, okay, the demand is normally 10 users. So you're going to build your infrastructure around maybe 12 users. But now when there's an emergency and 50 users try to use it, there's not enough infrastructure there to carry that demand. That's one of the cool things. The other nice thing is that, well, as I mentioned, really, you're in control of your own communications. You're in control of your own destiny in that respect. You're not relying on anybody else to help you communicate. That being said, you also do need to be aware that if you are trying to hide from somebody and you start talking on your radio, you become pretty easy to find. It's pretty easy to triangulate radio signals nowadays. Matter of fact, a lot of your amateur radio clubs do it for fun. They have what they call fox hunts, where somebody will take a radio and they'll go hide somewhere and talk on low power, and everybody drives around, walks around, tries to find them just by using directional antennas and stuff like that. So it's pretty easy to do that. So don't think you're going to communicate and be hidden from the government, if you will. That's not actually going to happen. The comment about the cigarette lighter plug, I think I'll address power demand, and then we'll wrap this video up and we'll come back into a series. So power demand is something to be aware of. Each radio uses a certain amount of power. They're a certain amount efficient, so you have to take that into account. But this radio uses 25 watts of, well, this radio produces 25 watts of output power. So you need to make sure that your power system can handle feeding this. Now, I can't remember exactly the efficiency of this radio, but let's just say it's only 50% efficient. And it produces 25 watts of power out the antenna and 25 watts of heat, which I know it's way more efficient than that. That means it's using 50 watts. So 50 watts divided by, say, 10 volts for a low 12-volt battery is 5 amps. So your power cord, your connectors, and what you're using needs to be able to handle 5 amps. Not too big a deal on this one. We start getting up into this with 100 watts of transmit power, and let's say it's burning 50 watts of heat. We're into 150 watts. We're on a 10-volt battery. Now we're at 15 amps. So now we're exceeding the capability of most cigarette lighters. And that's why I said don't do that unless you turn the power down on the radio. So you could put a cigarette lighter plug on that. You could plug it in. You could turn your power down on the radio to a safe level. What I would do is I would make up a bunch of cords. I would probably get some Anderson power pole connectors. And I would have some with alligator clips that you can plug onto your battery directly. But ideally, the closer you can connect these to the battery, the better, especially in a permanent installation. If you're putting one of these in your car, if you can run these right to the battery, you'll get a lot less alternator noise and computer noise potential in the radio because you're wired up closer to the battery. But that's one thing to be cautious of, is the power consumption. The other thing, if you're doing some kind of like solar powered battery, you might notice that the charge controllers all make a lot of noise, electrical noise into the radios. So if you're planning on communicating during the day, you may want to shut that charge controller off while you're talking on that radio. So if you notice that your noise is really high on one of these radios, that's something you can try to turn it down. So I think that's about it. I mean, really the goal of this video was to just kind of give you a primer of amateur radio, show you where to go, talk to like-minded people, find a local club, go on Facebook, search for amateur radio, ham radio clubs in your area, start chatting with them. They're all really great people. Learn the equipment, talk to people, watch a lot of videos. Don't just go out and buy a whole bunch of equipment and hope it works when you need it. You know, get involved in it. Most of the radio clubs, like our local radio club, does communications for a lot of events, canoe races, bike races, you know, dog sled races, all sorts of stuff like that. And then they also do things they call field day. And field day is a very common thing. It happens once a year. I think it's around July, June or July. And what they do is they take a whole bunch of equipment and they go up and set up in the middle of a field, power it with either generators or solar power or something, and they see how many contacts they can make around the world. And that's one of the fun things, is like I encourage you to try that. You know, take your radio, jump on your side-by-side, head out into the woods somewhere, pack a lunch, connect this thing up to a battery. I suggest bringing a second battery, not using the one in the side-by-side, because if you're not paying attention, you'll run it dead. But bring a battery, connect this up to a battery, throw an antenna up in the trees, and just see who you can hear, see who you can talk to. You know, just have a little fun with it. Make sure your equipment works so that when you do need it, you'll know how to use it. So yeah, we'll go from there. We'll bring you back. What we'll probably do when we bring you back is show you how some of this stuff actually works. We'll actually use it. We'll make some antennas or show you some antennas, show you how to power some of this stuff, and just generally go from there and try to give you an overview of how to make some of this stuff work to do what you're going to need to do in whatever application you're trying to accomplish. So thanks for watching. Don't forget to like and subscribe.